Okay, so welcome back to week 2. And so before we jump right in, let's take a recap of where we are. Because when studying a big topic like physics, it's very easy to get lost in sort of the nitty-gritty details of sort of the day-by-day or lecture-by-lecture material. And because every new concept is very complicated and you dedicate a lot of energy in looking at a specific tree, and it's very easy to forget about where you are in terms of the forest, right? So hopefully I'm not just showing you all the physics skills or physics knowledge per se, but also sort of general studying technique for any daunting subjects such as physics. So let's see where we are and where this takes us. Hopefully there's a coherent story in throughout all of this, right? So okay, so let's look at the first thing we study in this course is vectors, right? And basically, vectors is the mathematics of arrows. Okay, so when we look at how to add, how to subtract, and how to scale multiply, right? So just to be explicit, I write scale over there. And okay, so that's very abstract, but it's a specific mathematics tool that we learn. Okay, so now once we know how to do that, in particular there's a geometric view and an algebraic view. When we realize that although it has magnitudes and direction, you can split it into components. We look at our first application, which is force, right? So force is something that has a magnitude, right? How strong, in some sense, that force is, and the direction. Otherwise, it's not a very useful concept. And so in some sense, that forms the chapter 1 and 2. Forces, we looked at first, what is it? The definition, the different types of it, and how to add them up, how to add forces, and finding the key concept of defining the key concept of net force, right? And we sort of alluded to this is the origin of motion. This is what causes motion to change. Okay, we'll comment a little bit more on that just to have a comprehensive recap. So the definition, look back at your notes. It's a push and a pull on an object due to a source that usually changes the motion. I'm not going to repeat that over here, but just to emphasize some of the key things we talked about. Type, right? There is contact forces and non-contact forces. And we talked about some special ones. The general ones where you have a general push or a pull. But if it's specifically by something, usually sometimes we have a specific name. For example, tension for the ones by a rope, a spring restoring force. We won't talk too much about it in this course, but you will in 3C. There's a big part about springs. Because a lot of things sort of have this elasticity property to it, but we're not going to deal with that just yet. We also talk about the normal force and more specifically is the normal reaction force, right, that reacts to something else placed on it. Friction, which actually resist motion or resist the tendency of motion, depending whether it's static friction or kinetic friction, etc. Right? So this is not comprehensive. You can look back at your book or previous notes. But specifically, the non-contact force is weights, right, or the force due to gravity by the planet. As far as I know, I live on Earth, so that is the gravitational force by the Earth, right, on some object. And we have a specific formula for weight, which is mg. Some of these have specific formulas as well. For example, friction is mu times n, and depending on what mu, etc. Okay. All right, good. So there's a lot of different types. And then we talked about how to add forces. And if it's in one dimension, it's easy, right? You just either add them or subtract them, depending whether if you have 2 or 3 or 4 forces, whether they each contribute to each other or do they oppose each other. In 2 dimensions, it's a little bit more complicated, right? You have to resolve them into their components, and that's where the idea of vectors or the mathematics of vector comes in. Anywho, we have objects that you can have a number of forces like this, right? So for example, this one, you break it into these 2 components. This one, you break it into these 2 components, if I can So draw it slightly more precisely, right? So you take a diagonal one, you break into X and Y. You take this one, break into its X and Y. You take this one and you break it into its X and Y, right? And then now you can start to add them vectorially and find out what's, so sorry, this is getting a bit messy, but these three original forces, and now you can add them vectorially and find out what's the net force. Probably it will be, let's see, these two alone sort of just pushes it that way, but this one also pushes it slightly backwards and upwards. I'm guessing this is probably not accurate or to scale, but just generally that would be the net direction or the resultant direction. Okay, from the three forces. Okay, so we have net force over here, and what does it do? And one of the key concepts we alluded to is that the net force or forces in general they're not necessary to maintain motion. They causes changes in motion. Okay, so so the net force is not needed to maintain motion, but it causes changes in motion. Okay, so all right, so this is basically the idea of Newton's second law. And where is this taking us, right? We talked about the word motion a couple of times, but we haven't really studied and defined what it means. I've threw around the word acceleration and velocity. So now we need to properly be able to analyze that. And that takes us to the topic of kinematics. Okay. So kinematics, what does this mean? It sounds like a very fancy word, but it just means the theory of motion. In fact, kin comes from the Greek root of speed or motion. Okay, so matics, like mathematics, is a study, and that's basically the study of motion. And in here, we'll basically talk about all these words, and we'll talk about it in the next video. We'll make it rigorous and make it formal once and for all, what I mean when I say these couple of words, because we're going to use them a lot, and we want to make sure you have a good idea of what they mean and able to use them and able to talk about them in a very precise and formal way, right? Position, velocity, and acceleration, these are the sort of our key players we'll see. And also, there's a lot of subsidiary, a couple of, let's say, cousins of these jargons. For example, displacement and distance. What's the difference between displacement and distance? What's the difference between velocity and speed? What's the difference between average acceleration and instantaneous acceleration? We'll look at all that in the next video.